Very good. Thank you very much, Diane, and thank you for the opportunity to finish this presentation. I apologize for the confusion at the session, and I still haven't figured out how I managed to delete a couple of slides, but I was able to recreate them and get going. And so I think if anyone has any questions as we go through, please just speak up. It would be just fine if you want to unmute your mic. And if you have a question, speak up. You don't need to bother to raise your hand. Just speak up, and we'll take it in stride. Okay, so with that, let me ask Luis, were you able to hear and understand everything I said there?
Yes, sir. Can you hear me?
Good. I just wanted to make sure that everything was being communicated. Well, the presentation got interrupted because I managed to improperly save my file. And so I'm gonna go through it very quickly. And I mean, I'm really gonna blitz right through it. Get to where we were the other night, and then I'll take you through what we call the tool for the inventory management control and how it works. It's actually very simple. Well, it's simple on the surface. Deep down, it's very complicated, but on the surface, it's very simple. And so the problem we have is one with inventory management, and that is how do we control the inventory without creating other problems, like lots of overtime or lots of expediting or some combination of all of those, and how do we keep our on-time delivery high? The answer is that there's no rational way that people usually use, but there is a rational way. The science and the physics of material flow apply to inventory management. And the key is that it's not just one person's task. The inventory is created by at least 3 different functions, and everybody affects the inventory that's created in a facility, but there's only a select few who are held accountable for it. Okay. And so we find that the people who are held accountable for it cannot necessarily change it. So if the inventory is too large or too small, sometimes they have a great deal of difficulty correcting those things. Okay. And the key question that we answer as we go through any sort of a project is who will do what by when, okay? And who will control the inventory, okay? And what we're talking about, usually most facilities have large amounts of inventory at 2 locations, as indicated by the red triangles. One is finished goods, which you see there circled in yellow, and the other is raw material. There's also WIP inside the process, but in today's world, there usually is not a great deal of WIP out on the floor. Most of the inventory is held in either finished goods or raw materials, okay? But the question is, how do we find the optimum level of inventory? And the point is, there's a science to it. It's not trial and error, and it's not whack-a-mole of trying to balance overtime with expediting, with on-time delivery, with costs, with all the financials. There's a way to determine what is the optimal point. Okay. So in our agenda, we're gonna talk about the benefits of inventory management. We're going to talk about the purpose, the 3-part inventory system, who's responsible for it, what is teamwork, what the management tool looks like, and that's what we're going to focus on here. That was the piece that I failed to include in the presentation the other night, was what is this management tool? What does it look like? Okay. And finally, we'll wrap up with who does what by when. Okay. So we talked about a company profile. We had a company that had about $130 million worth of sales. They had net profits of about $5 million. And using this model, what we did is we reduced their inventory at the same time we improved their on-time delivery. Their stated on-time delivery was 98%, but that included a lot of overtime, that included a lot of expediting. And when you use the lean metric of full load, non-expedited on-time delivery, their actual number was 76%. 1 out of 4 shipments, they were either shorting or shipping late. Okay. We got it improved to 99.6% in less than 6 months. Okay. We reduced the finished goods inventory by $2.3 million a year. That year, they booked $2.3 million of additional earnings, okay? Compared to their net profits were only 4.9 to begin with. So this made a substantial improvement. It literally improved their profitability by almost 50%. And then because they're now carrying less inventory, they have less carrying costs, less obsolescence, less waste, less materials handling. It reduced their carrying costs by $500,000 per year for every year going forward. And actually that number increased because we reduced the inventory below 1.9 million. Okay. In this time period that we're talking about, the 6 months, we reduced the inventory turns from 31 to 67, and it was rising each month. And the example that I'm going to show you, we actually got to over 300 inventory turns. 300 inventory turns. Basically, we were making product and shipping it the same day. Okay. They began to improve raw materials inventory management. And what did they need to do that, to get that accomplished? There was no capital investment. They spent about a half a man year of IT involvement and about $60,000 worth of consulting fees. And they had to hire 2 process engineers to work on problem solving processes, which saved them another several million dollars a year. Okay. Those were the outlays that they needed to make. Okay. Keep in mind that in manufacturing, your purpose is to supply good quality product to your customer at a fair price. Quality is 0 returns, and just in time means full load, non-expedited on-time delivery per the shipping plan. Okay. Okay. What it costs to do this, almost everybody has very, very high on-time delivery. But at what cost? How much are they spending on overtime? How much are they spending on expediting? How much are they spending on inefficiency on the floor because they changed the schedule and move things around? Usually these costs are extremely high and they're almost never quantified. Okay. And the question is inventory really a waste? Well, you can't handle a manufacturing plant without having some inventory. Well, you can, but it's very, very expensive. Okay. So is inventory a waste or not? Okay. Well, it turns out that inventory, the purpose of inventory is to handle the variation that you have in the system. Whenever you have variation in your system, you need what's called a buffer. Okay. And we went through the example in the plant about how we put material in front of and after a cell workstation that varies, and then you can attain the average rate. If you don't have that material, then the rate that you will be able to achieve is much lower. Okay. So we need to think of inventory as the shock absorber in your system. It's the shock absorber that allows you to run your plant at a fixed rate and ship at a variant rate. Okay. And the variation is taken up in the inventory, not in the plant changing rates. It's very, very inefficient to change the rates each and every day of what happens in the plant. You want your plant manufacturing processes to be as stable as possible. Okay. So all of this must be coordinated with shipping. It must be coordinated with receiving. Okay. But the bottom line is this: what is the purpose of inventory? Inventory is a natural system response to variation so that you can sustain average rates. Just like we went through with the example in the work cell, as long as we had material in front of and material behind that workstation that varied, we could maintain average rates. But if we didn't have that inventory, then we would suffer some inventory loss. Excuse me, some rate loss. Okay. We talked about buffering. There's really 3 types of buffering. And all of the buffering can be calculated by the rules of factory physics. Okay. All you need to know is the demands in and out of the warehouse, the average rates, and you can calculate the needed inventories. And once you can calculate the needed inventories, you can say, okay, how do I optimize the inventories while maintaining high full load, non-expedited on-time deliveries? Okay. So let's talk a little bit about buffers. There's 3 that you can use: capacity, inventory, and time. The one we're talking about here today is inventory. Okay. And the aggregated sources of variation when we're talking about inventory are 2. if we're talking about to our warehouse, or if we're talking about WIP, or if we're talking about finished goods, or if we're talking about raw materials, it doesn't matter. The source of variation is the rate of arrivals to and the rate of departures from the warehouse. Just imagine for a second that exactly what you're withdrawing from the warehouse, you're also feeding into the warehouse. You would need no inventory if those two rates are perfectly balanced, okay? And that's the essence of a manufacturing cell. In a manufacturing cell, you want the rate of arrivals of parts to a workstation to be equal to the rate of departure, okay? That's the beauty of a work cell, okay? Now, in our system, in our manufacturing system, we're going to find that we need a three-part inventory system so we can manage it, okay? We'll need, there are three major sources of variation that create the need for inventory, okay? And they're governed by three separate organizational functions, and this is the key. Those three sources of variation are created by a function that normally is not accountable for the inventory. The one function that's expected to be responsible for the inventory, maybe it's purchasing in your facility, maybe it's logistics, whatever the function is, usually the plant manager or the vice president of manufacturing goes to somebody and says, okay, we've got to reduce this inventory. What can we do about it? Well, that person very seldom can make the changes that are needed to reduce the inventory and sustain on-time delivery, okay? So the problem is that the persons responsible for the inventory do not create the need for the inventory, okay? So we looked at the three-part inventory system, and it has production, okay? And the first source of variation is what we call internal sources of variation, and that's the variation of the rate of arrivals into the warehouse in this case, okay? And that creates a need for what we call safety stock. There's external sources of variation, all the variation that occurs downstream of the warehouse in your shipping, crossing borders, weather problems in transit, whether you're shipping by train or whether you're shipping by truck or air. And that variation creates the need for what we call buffer stock. Very often the single greatest source of variation is your customer demand, varies from day to day. Okay. And finally, when a truck arrives or a transport arrives to pick up inventory, you need a batch size that can be picked up, okay? And that's called cycle stock, okay? These terms are not universal. They're the terms that I use. They're the typical lean terms, but you will find in other systems they give them sometimes different names. Safety stock is internal variation. Buffer stock is caused by external variation. And cycle stock is the need to be able to fill up a truck quickly, to have a pile of material on hand, okay? So when we talk about inventory management, let's talk about who's responsible for it, okay? We've got the three stocks, buffer, cycle, and safety. And in your warehouse, they might be all aggregated into one location, okay? But there's three parts to it, okay? And the absolute volume of each of these is a function of the variation. For the buffer stock, it's the variation, excuse me, for the safety stock, it's the internal variation. Normally that would be handled by the production manager. Is he complying with the build to schedule plan? Is he really sending the material to the warehouse in the right order? Okay. The second is the buffer stock, and that's external variation, usually handled by the logistics manager, sometimes the customer service rep. Okay, but the biggest source of variation there is just the customer's pickup volume. Do they pick up a different volume each and every time they come in? Okay, and finally, the cycle stock, what is the absolute volume that they do pick up? Okay, so what we need is we need a team working together towards a collective goal. Okay, I showed you this graph, which shows a high variation into the warehouse and a high variation out of the warehouse. On the other hand, if they have a low variation out of the warehouse and a high variation in, you get a different inventory requirement. But if you have low variation in and high variation out, okay, you get yet a smaller demand. We can measure the variation by this term here called the coefficient of variation, which is the standard deviation of the variation divided by the average amount, okay? When the coefficient of variation gets higher than 0.3, we call that high. When it's less than 0.1, we call that low, okay? And the point of this is when you have both the rates of arrival to the warehouse and the rates of departure from the warehouse in a high variation situation, you can have 10 times the relative amount of inventory as if they're both low. 10 times as much inventory just by the function of this variation. Okay. So variation is the enemy, and it's what creates the need for inventory. Okay. And so what we come to is the concept that inventory is a waste if and when you have more inventory that is needed to cover sales. Okay. And we'll show you how you can figure out the amount of inventory that you need to cover sales and have yourself protected so you can have 99.99+% on-time delivery. Okay. The one genius piece that the Japanese had that actually there was two that were not really part of the American system. The American taught the Japanese most of what they did. They just did it much better with a far greater degree of discipline. But this is a picture of the first house of Toyota, okay? The first documented picture of the Toyota house. And if you'll notice here, this is the first definition that they had for respect for humanity. You might hear it called the respect for people, okay? But it's a key part of the Japanese culture. The second piece of real genius that they had was load leveling production. It's called Hijunka, how to get the variation out of the system. And what it amounts to is small batch production, ultimately dealing in the ideal state of one-piece flow. This is pure genius by the Japanese, and it's something that still American companies do not really appreciate. The power of Hijunka. Okay, both of these are pure genius. Okay. So your problem is if you fail to understand where the variation is, then you fail to understand how to reduce the inventory. Okay, it leads to bad or non-existent goals, no means to achieve the goals, confused responsibilities, poor alignment, poor focus between planning, production, shipping, and finance, and ultimately creating angst and impacting morale, not to mention costing you a whole bunch of money. Okay, so it results in very expensive on-time delivery, lots of bad decisions, and excessive costs to produce. There's a lot of money to be made by carrying the right amount of inventory, not too much, not too little. Okay, so in terms of inventory goals, we've talked about this. We want enough to protect sales, and that's all we need. Okay, it normally plays out this way. In most plants, they want to make sure they have high on-time delivery, because if you have low on-time delivery, your customers all over you. Okay, but you want to do it at a minimum cost. Okay, now neither one of those are usually very well defined in most manufacturing plants. Very few plants use full load, non-expedited on-time delivery as their metric. If they can keep the customer happy, that's all they care about. So they may ship some things early and others late, but they'll give the customer a call and say, hey, don't worry about it. You know, we'll get this on the Thursday shipment, even if we don't get it today. And they play this kind of negotiating game where they negotiate into an on-time delivery situation. Okay. Okay. Now the bottom line is what happens in most plants is that on-time delivery gets a whole lot more pain than a little bit of extra inventory. Okay. If you miss a delivery, the stuff hits the fan very quickly. And so what happens is very slowly, but very surely, to protect that on-time delivery, whoever's in charge of that inventory, make sure that there's plenty of the inventory there. So almost always, I have yet to see an example where we could not go in and reduce the inventory. And what I found is the average is 38%. 38% of the inventory we can reduce and turn directly into bottom line profits. Okay. Here's a little bit of about decision making, and I'm going to skip right through it because it's not germane to what we're talking about here. Okay, we talked about teamwork, and what are the elements of a team. And if you remember, the key term to a team is that this key element of interdependence. In other words, the performance of one person dramatically affects the performance of the other people. Just like if the production manager does not maintain his bill to schedule, then the inventory is going to go up. Okay. And that's going to affect whoever's in charge of the inventory management. Okay. And so we talked about various types of teams. There's collections, there's groups who have more interdependence, and ultimately there's real teams. And real teams, the performance of one person affects the performance of the other. It's like a basketball team. You can take the 5 best basketball players in the world and put them together, and you may not have the best basketball team. Okay. Because the performance of one is so dependent upon the other. And you know, in a basketball team, you need somebody to rebound, you need somebody to play defense, you need somebody to pass the ball, you need somebody to get the ball inside to the big guys, you need somebody to shoot, you need somebody to shoot from the inside, you need somebody to shoot from the outside. And all of those people have to work together in a cohesive unit. Okay. And you find that the ultimate team, in my opinion, is a Navy SEAL team. I've spent some time with Navy SEALs and talked to them, and the way in which they work together, and the way in which they manage their work environment is just incredible. It's just amazing. And here is where most planning and inventory management systems are. They're at a fairly low level of interdependence. People are doing their own thing. The production manager is making sure that he does what he needs to do. And maybe it's not in the best interest of the corporation. The purchasing manager is making sure he's got plenty of inventory so that he doesn't miss any shipments. Meanwhile, the financials are hurt because of that. And so the people are not interdependent. They're working towards their own goals or their own group goals instead of towards the corporate agreed upon goals. Okay. And to me, this is the number one coordination, alignment, and focus obstacle in business today, is that are people, are groups willing to subordinate their individual and their group goals to the overall corporate goals? Sometimes that means somebody's got to work overtime because that's what's best for the corporation. Okay. And that may be contrary to their individual goals, but can they set that aside and work for the best interest of the corporation? That's a huge problem, a huge problem. Okay. Now we talked about who is supposed to do what. I'm going to skip through this very quickly because we just went through it. Okay. And this is where we ended our session the other night. Okay. And so where do we go from here? Okay. The key answers are who will do what by when. Okay. Now we talked about these inventory systems. We're talking about the inventory system here of finished goods. Now the same logic applies to raw materials, but we're going to talk about finished goods just so we have an example to talk about. Okay. So the solution to how we handle this is that, number one, variation creates the need for buffers. That's our enemy, variation. Okay. The most common buffer is inventory. Actually, in your plant, you probably have a couple of other buffers that you do not think of as buffers. Okay. One of them is overtime. One of them is weekend work. One of them is expediting. Those are what I call hidden buffers. Okay. They cost money. People don't usually pay a great deal of attention to them until the bill gets very big, but they can be a creeping source of loss of profit. Okay. The third piece of the basis is that inventory is money in the belly of the beast. In and of itself, it does no good. It does no good unless it's protecting sales. Okay. So any inventory you have above what's required to protect sales or to protect shipments to your customers is waste. Okay. And we're going to show you how to get rid of that waste. Okay. But to reduce inventory, we first must reduce variation. Okay. Reducing the inventory, there's no danger to that. Okay. I mean, there's no difficulty in that. Pardon me. All you have to do is reduce it. Okay. But you pay a price for it. And the first price you're going to pay is poor on-time delivery. Okay. And inventory creation is a function of 3 sources of variation: internal variation, the variation up to and including going to your warehouse; external variation, all the variation downstream of your warehouse; and the pickup volume batch size. Those are the three sources of variation that we must handle. Okay. And creating the need for these three inventories, we have safety stock, buffer stock, and cycle stock. Okay. That's the solution. Okay. Now, the procedure is the leadership must create clear inventory and delivery objectives. They must be understood by everybody. Everybody must accept responsibility for their contribution. Okay. And then the third part is we will show you how to do real-time analysis and problem solving using an agreed upon process. Okay. And finally, the problem solving tool you use is PDCA to continually improve. Okay. Now, the tool that we will use is an extremely large Excel spreadsheet, but it's just an Excel spreadsheet. Okay. And your planning people, I'm sure, are more than skilled in creating this spreadsheet. Okay. Now, it's very complicated because there's all the SKUs in it, and you have to calculate the various sources of variation. There's some statistical logic that you use in how you calculate the amounts that you require. And you calculate the amounts you require based on the probability of missing a shipment. Okay. And in this spreadsheet, everything is calculated to 99% on-time delivery. Now, you can calculate your spreadsheet to any level that you want. Okay. And the lower the level of on-time delivery, if you're willing to live with 95%, okay, you can reduce the inventory dramatically. Okay. But then you got to answer, how do we handle that on-time delivery? Okay. And if you have a facility, this facility ran 3 shifts a day. Okay. So they didn't have any makeup time. Okay. If you run your plant like a Toyota plant, you run it 2 shifts, 10 hours a day. Then between each of the shifts, you have a 2-hour block. Okay. So if something happens and you have to reduce inventory below minimums, you can make them up in that 2-hour window. Okay. So if you have this excess capacity, you can run with different levels of probability in your system and allow you to carry lower inventory levels. Okay. There's a lot of statistics that goes into it, and we're not going to get into all of it, but if you have questions, please don't hesitate to ask. Okay. But the spreadsheet is built into 3 basic areas. There's shipping and planning information. It's the basic data in the system. There's a series of calculations where you calculate the buffer, the safety, and the cycle stock. And then there's the results. Okay. Now, this tool would be run every single day. And if you want to, you can put it in live mode so that it's updating as shipments are made. Okay. We normally don't recommend that. Okay. Because it's not needed. Okay. And what we typically do is run this, and at midnight, most people backflush their inventory. And so they know what they've got in raw materials. They know what they've got in finished goods. Okay. And they backflush based on their shipments. Okay. And so at midnight, you have an inventory resolution. Okay. In this spreadsheet, that's what was downloaded to the file. Okay. Now, I'm going to show you 2 spreadsheets. The first one was March of the first year that we did this in this facility. And it wasn't at the very beginning. If I'm not mistaken, we did this in February. But this shows what we had done at March, and I'll show you what the spreadsheet looks like. Somebody's going to have to tell me if the letters on here are big enough, or I should make them smaller. Adrian, can you read the numbers on the screen?
No, sir, I cannot.
They need to be bigger?
A little bit bigger.
Okay. How's that? Or bigger yet?
This is
Bigger.
read. I can read those very well.
There you go.
How's that? Okay. Is that good enough? Antonio, can you read those?
Yes, perfect.
Okay.
Thank you.
Okay. Well, let me show you the layout of the spreadsheet. It's gonna be a little bit difficult at this size, but on the left-hand side, we have all the product codes. Okay. And here you'll see product code. That's an SKU. Okay. And for each one of them, we have how much was released, how much was actually shipped, and the variance. Okay. And you'll notice here, see, this is line 12. if we go down to the bottom of this spreadsheet, we're at line 200 and something. So there's at 4 lines, there's about 50 SKUs in this database. I'll scroll back up to the top. Okay. And we have all kinds of data in here. These are prior shipments. And you can see all of this data that you see here. All of this was downloaded at midnight from their ERP system. And it showed what their plans were. Okay. And you'll notice here we have the by week here. Okay. We have every day what the shipments were. And then here is the operating plan. And this is shown as daily requirements per week. Okay. So the week of April 22nd, for this part number, they had to manufacture and ship 396 pieces a day. Okay. You'll notice back here that there's most of these numbers are the same. Okay. But here you'll see some variances. Okay. So here, and please don't ask me to tell you what the variance was, but they had planned on shipping 574, but they only actually shipped 374. So there was a variance. They undershipped. Here they undershipped. Here they undershipped. Okay. And then you can see that they made that up in later weeks. Okay. That's poor on-time delivery. Okay. And at this point, they were operating at like 76% on-time delivery. Okay. So that's the data that we use to calculate all the historical values. Okay. Now here is the calculations that we use. Here's the lean calculations over here with my cursor. But here you can see we start the calculations over here. Here's the some relatively these numbers are not going to mean very much to you, but here is the average shipment over that time period. Okay. It turns out we use pieces per hour in the calculation several places. Okay. And here's the standard deviation. Here's the variation. Okay. The average was 206 pieces per day, per shipment. Okay. And it averaged plus or minus 96 pieces as the standard deviation. Okay. So now we want to say, okay, how many standard deviations do we need to carry? If you remember your statistics, 2.33 amounts to 99% on-time delivery when you're doing a one-sided calculation. Okay. And so the buffer stock we need is 223 pieces, which is 2.33 times 96. Okay. So there's the buffer stock calculation based on the variation, which is based on the shipment frequency. Okay. We now know if we carry that amount of buffer stock for that product, we will meet the delivery 99% of the time from that piece of the variation. Okay. But then the cycle stock, the average load, the high load is 154 pieces. So we figured that we need 154 pieces in stock to take care of the cycle stock. In other words, when a truck showed up, okay, that's what we needed to do. Okay. Now you may wonder, since the daily shipment was 206 and the average load was 154, how did those numbers make any sense? Okay. Well, this was the large load. It was not the average load. Okay. And this product, they may pick up more than once a day. Okay. Actually, this supplier came and they had 6 pickups a day. Okay. And they had 6 trucks that would come by, and they would load up these 6 trucks with varying quantities of materials. And so actually you could have 6 loads a day of any given part number. That didn't happen, but that could happen. Okay. So there's the buffer stock, due to the external variation. Okay. Here's the cycle stock due to the pickup volume. Okay. And in this case, the safety stock was very easy to calculate because there was one overriding factor in the plant. This plant had a robot, and if the robot should fail, they had an emergency plan that it took 12 hours to replace the robot. Okay. And so they carried 12 hours of safety stock. Okay. So 12 hours, and remember this piece over here of 9 pieces per hour. So 12 times 9 is 113 pieces. Okay. So now you say, okay, here's the buffer stock, 223. Here's the cycle stock, 154. Here's the safety stock, 113. So the maximum lean inventory for that part is 490 pieces. And if you have 490 pieces on hand, okay, you will protect yourself 99% of the time. Okay. So then you do that for every piece. Each piece is a unique circumstance. Here for this part number here, okay, the standard deviation was 190 pieces. Okay. So the buffer stock was 440. The cycle stock was the pickup load of 336, and the safety stock was 14 times 23 times 12 hours, 14 times 12 hours, 171. So the maximum lean inventory for that is 950. Okay. So we go through each and every one of those, okay, and we find out what the total inventory is. Okay. So now we have calculated the inventory. Okay. Now keep in mind that at midnight, we knew what was in the inventory because the back flush was taken care of, and the inventory calculation was made, and the information was downloaded. Okay. And here it shows you how many pieces we had on hand. Okay. Now they did some funny things with this, and they did a variety of things. But here's the inventory that they had. Okay. The quantity that they had on hand for this part number was 350 pieces. Okay. The lean inventory max was 406. So they were within the range. Let me see if I can show you that. Here's the min, 173. Here's the max, 406. They had on hand 350 pieces at the beginning of the day. Okay. And notice this is coded green. Okay. What that means is that it's between the min and the max. It's perfect. Okay. We're set up for the day, and we're gonna produce just fine. We're gonna be able to deliver on time, 100 with 99% certainty. Okay. So now if we scroll down this, okay, keep in mind that this number quantity on hand was just downloaded from our midnight inventory resolution. Okay. And so we go down here, and here we find one that's yellow. Okay. And what's the problem here? Okay. The min on hand was 19. The max is 128. And for some reason, they have 140 pieces. So something changed. Okay. And it says yellow. Okay. That means the inventory is high. Okay. So that means the planner has to stick his nose in that and say, what happened there? Did we miss a shipment? Did we miss a load? What went on? Okay. But all they have to do is look at the yellow ones, and let's see if we can find a red one. You see there's several yellows, and those are over. Okay, here's a red one. Okay. And here's a red one. The minimum was 1 piece, the maximum was 78. Okay. And they had 0 on hand. Okay. So that means if that product comes up today, we're not going to have the product on hand. Okay. So these are coded, color coded, red, yellow, green. Okay. Red means that you have insufficient quantity on hand to take care of the demand on average. Yellow means you have excess product and you need to adjust the production schedule. And green means everything is good. Okay. So let's look at, this was March of that year. Okay. And let's look at this. And you can see here, this is what the materials manager would look at when he first comes in at the end of the day. Okay. He would say, okay, I've got 1 product that's under range. We found that one. We've got 16 that are over range. Okay. So that means I'm making too much product. I've got too much inventory, okay? And within range, I've got 34, okay? The first time we did this, this number was like 30, this number was like 20, and this number was like 5, okay? We were way, 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 way off. And this is a month into correcting things, but you can see we've taken care of almost all of the insufficiencies, okay? So now what we have to do with is overproduction, okay? And if you'll add this up, there's one that's under range, 16 that are over range, and 34 that are within range. So that's in this database, there's 51 SKUs. Okay, and remember this number. Somebody write this number down right here. This is the total inventory that they have on hand, about 16,000 pieces. Okay, and you can see that they're over range on some products. Okay, what happened in the next 60 days? Okay, before I leave this, okay, because I want to take you to the next spreadsheet, which is 2 months down the road. Do people have any questions about how the data are gathered, how the calculations are made, and how the decisions are made?
It's clear so far, Lonnie.
Okay, who is that?
Omar,
Omar, okay. It makes sense to you?
makes totally sense.
Okay, so everything is calculated. There's a science. Now let me show you what happened after 3 months, after 2 months. You'll notice this is March of year 1. Here is May of year 1. Okay. Okay, let me get these big enough so we can read them. If I'm not mistaken, that was 120. Is that readable?
Yes, sir.
Yes.
Okay. So you can see we've got the same database. You'll notice that this starts a little bit later, okay, because it's later in the year, okay? But there's the same data. Okay, and we go into and the calculations you'll find will be very, very similar. This is the new production schedule. Okay. And you'll notice that, remember, this was 11 pieces an hour. At the new production schedule, they're demanding more of this, okay? But notice that the standard deviation is smaller. Remember that? Okay. And it yielded the demand is higher, but it yielded actually more buffer stock, but more buffer stock because the volume is up. Okay. But here for this part, here's the buffer stock calculation. Here's the cycle stock calculation. And here's the safety stock calculation. Okay. And so here's the maximum lean inventory. Okay. And the calculations again are dynamic. Okay, based on the formulas that we put in there. Okay, so here's the lean inventory range. Okay, the minimum for that product was 295, the maximum was 611. Okay, if you remember last time it was 173 and 450. Okay, and that's because the demand has gone up. Okay, and likewise the variation has also gone up a little bit, I guess. Okay. The quantity on hand is 425. Notice that at midnight, that's right nicely between the min and the max. Okay, and so you get a green coded inventory. Okay, and so if you look down this, I'll scroll down it. You'll find out that I think everything is green. Okay, and when we get down here and we look at the summary statistics. Again, if you're the manager and you're coming to work this morning, February 28th or whatever day it was, okay, you get this spreadsheet out and hopefully you've got a bigger screen than I've got, and you look at it and you say, holy mackerel, of my 51 products, 0 are under range, 0 are over range. We're perfect. I've got nothing to do. The production plan is working, the shipping plan is working, everything is working. I've got the material that I need on hand, so I can look at my next spreadsheet. Okay, now this handles 51, and this plant had about 400 SKUs. They had, I think he had about 5 of these spreadsheets. Okay, but it literally takes about 2 minutes to go through it. He goes through here and he looks at this and he says, man, I got no problems on that customer. Okay, now this customer was TS Tech, which happened to be Toyota. Okay, the Toyota plant. Okay, but this plant is now in great shape. Okay, and if you remember the inventory that we had on hand last time, the total inventory, remember what that number was? Anybody remember it? That quantity on hand?
15,000,
Yeah, it was almost
15,000.
16,000.
yes.
Okay, and now we've reduced it by almost 2,000 pieces. Okay, now if you're familiar with the term inventory turns, we have 2.2 days on hand. Okay, this plant was running almost 300 days a week. They were really stretched. Okay, so this product was at about 140 inventory turns. Does anybody in their plant have 140 inventory turns on finished goods? I see very, very few plants that are over 50. Okay. And this plant, this product slate itself, we got to over 300 inventory turns. We had less than 1 day of material on hand. Okay. And the way we did that, let me show you how we did that. It's not very complicated. Okay. Let's scroll up to the top. Here's the production plan right here. Okay. And notice it varies from 286 to 352 to 264 to 132 to 110. But if you'll notice something, look at this week. But let's look at this week. Okay. And there's 858 pieces there, huh? But look at it, varies from 400 pieces a day to 120. Let's look at this week. They're at 700 pieces, okay? And it varies from 240 to 44, okay? But the whole week, it only varies by 100, okay? So what we did is we took this variation out. Instead of making these this way, we implemented what we called Hijunka, okay? And so for this week, instead of making 110 and 150 and 150 and 44 and 240, okay, in 5 days, if it's 700 pieces, okay, we made like 150 pieces every day. Okay, so this day we increased the volume, and this day we increased the volume, and this day we decreased the volume. Okay, and as soon as you do that, what have you done to the variation? You've reduced the variation. Okay, now let's look at what impact that has. Okay, if we reduce that variation, okay, we're going to reduce this number right here. Okay, wait a minute. That's the releases there. Okay, and if we reduce that number, we're going to reduce this number. Okay, because this number right here, the inventory we have to hold, is the probability that we're going to have a problem, 2.33 times the standard deviation. And let's say we can reduce that to 50. Let me see if I can do this. Okay, if I reduce the standard deviation to 50, notice this went from 230 or 250 to 117. We reduced the variation. Okay, now we have to reduce the variation in the releases, which is the inventory going to the warehouse. And if we can do that, now we can reduce the inventory here in buffer stock. And when we reduce the inventory in buffer stock, okay, then we reduce the minimum inventory, okay? And we reduce the maximum inventory. Remember that maximum was 650, okay? And now if we get something above the maximum, okay, we can reduce our whole production, okay? And so by solving these real-time problems of reducing inventory, and Hijunka is the key to it, we're able to reduce the safety stock. We're able to reduce the buffer stock, okay? And by reducing the safety in the buffer stock, we reduce the overall stock. And pretty soon we get to the point where we're still at virtually 100% on-time delivery. They got to 99.6%. Full load, non-expedited on-time delivery. Okay. And the reason that they missed a couple of deliveries had nothing to do with inventory. They had problems with, they had some safety problems in the plant, and they had a gas release, and they weren't able to load some trucks. Okay. And that's why they couldn't meet their 100% on-time delivery. Okay. But the point being that now you can control the inventory by controlling the variation. As you reduce the variation, you reduce the need to carry inventory. As you reduce the need to carry inventory, your inventory drops and you still maintain on-time delivery. Okay. So the beauty of it is now people can control what's going on with the volumes. Okay. Now, does that make sense? Please ask a question if you don't understand. Okay. It's all simple math. Okay. But everybody has to do their part, and that's the key. That's the key to it. Everybody has to do their part. Okay. So let me take us to the very end of this. This is the results. Okay. There are a couple more slides. One is I want to introduce you to two of my new books. Okay. These are two books that I've written, one in 2021, one in 2022. And these are the Spanish translations. Okay. And these are the finest Spanish translations you're going to find. Luis Martinez did it, and many of you know Luis. His English is impeccable, and of course, Spanish was his first language. And he's an expert in lean manufacturing. So you're going to find these to be two of the finest translations. Pardon? Hello? Hello. Were you able to hear me, Luis?
Yeah, Lonnie, and thank you.
Okay. And both of those are available in Amazon. There is the, does somebody have a question? Okay, I thought I heard somebody. Well, if you have a question, speak up. That's no problem. But those are two of my books. There's the other ones are all available in English. These are available in English as well. Okay, but they're available in Spanish. Enlarging your problem-solving footprint is also available in Chinese if you want it. Okay, but I want to thank you, and the calculations that we talked about are available in this book here, How to Implement Lean Manufacturing. We gave away a copy or two of that at the workshop, and someone put on LinkedIn their picture with it, and I was very proud to see that. So thank you very much. And last but not least, I'm available for any questions. And there's where you can contact me if you want to. Questions, comments, additions, deletions. Oh, come on, we got to have some questions.
Not any question or comment, Chet. Probably some idea to closing.
Well, one last thing, I will send a copy of these slides. Unfortunately, I will not be able to send the spreadsheets. And the reason for that is that there's proprietary information buried in the calculations and that sort of stuff. And there's parts of the spreadsheet that I didn't show you. But short of the spreadsheets, I will send you the entire slide deck. I'll send it to Diana as soon as we're done with this conversation. And you can have those and they're in PowerPoint format. So if you want to convert them to PDF, that's up to you. Or if you want to just keep them in PowerPoint, that's available too. They'll be in dynamic mode.
Okay,
Questions?
we will share it in both formats, Lonnie.
Okay. Very good.
Okay,
Lonnie,
okay.
Yes,
I have a question.
sure.
So, I don't work in manufacturing. My company, I work in the oil and gas. I think this is more oriented to manufacturing, but I'm trying to find some similarities in our business. We don't use Hijunka, but I found that your scenario where you have two inventory points, that is actually what we implemented. A little bit of a background, just to not drag this meeting too long, is we have special units that go out to location to the wellhead, and then the way that I guess that we mitigated rig time is that we have Connex with inventory in it. It's not all the inventory that we have in the warehouse, but it is similar to, let's say that we have $5 million in inventory, they carry around 200 grand worth of inventory.
Mhm.
So it's very refreshing what you're saying. I guess the pathway that you're putting down for us, I'm very interested. I just wanted to share this with, I guess, with the group, that it's not so much just for manufacturing. There is some similarities on other scenarios for inventory warehouses. So I just wanted to share that with you.
Yeah, there is. And just as an aside, Adrian, I don't know if you know, but my background is in petroleum.
Yes,
I
you work
worked
for
out in the oil
Chevron.
fields and I spent 20 years with Chevron. And we actually used a great deal of this in our inventory management systems, particularly in handling intermediates and setting up how to run the blender and that type of stuff. And there's an awful lot of parallels. The big difference is that in petroleum business, usually you're running 24 hours a day. And so you have no flexibility for catch up. Any problem is a crisis. That's one problem.
Yeah.
And the other problem is that the problem, the products are very fungible. There's if you're in a manufacturing plant and you're making, I don't know what, radios, the radios are very discrete and each radio is unique. Each model is unique, I should say. But in the petroleum business, an awful lot of the stuff that goes into gasoline can also go into jet fuel, can also go into diesel, can also go into aviation gasoline, can also go into lighter fluid. The raw material is very fungible, as opposed to being very discrete. And so there's some other things that happen. But if you would like to spend some time talking about how these overlap in the oil industry, give me a call. You've got my number there, and I'd be more than glad to share it with you, because there's a lot more overlap than people think. The principles are pretty much the same. You got inventory, you want to minimize it, you want to keep the product flowing. And in fact, the thing that's interesting is in the oil business, we learned how to make things flow back in 1920. And that's the key that's being done in lean manufacturing, is to get everything to flow. And the shame of it all, Adrian, is in some ways in the discrete parts business, they're better at making things flow than we were in the oil business.
Yeah, we're
But,
always on the go. That's the main thing.
If you want to give me a call and catch me, not now. I have a meeting here in about 15 minutes I need to go to, but tomorrow or the next day, give me a buzz and we'll get on a Zoom call and talk about this.
Sure will. Thank you very much.
You betcha.
Appreciate
Thank
your
you.
time, Lonnie.
Thank you.
Thank you.
Any other questions? Okay, well, I have a meeting that I've got to prepare for here in about 10 minutes, so I will sign off, but I want to thank you tremendously. Thank you, Chet. Thank you, Diana. Thank you, everybody who attended, Karina, Luis, Adrian, Antonio, Omar. I think Omar is still up there. I can't see his name, but I appreciate your looping back and give me a chance to finish the presentation. You all have a good day, and if I can be of any help, please call.
Thank
you.
you.
Thank
Thank you
you.
to all. Good to see you all. Thank you.
Okay, with that, I think I will sign off.
Yes,
Okay,
thank
Lonnie.
you.
Bye.